Very happy to introduce Ram, who's leading he's CTO for our blockchain effort inside Cisco, I believe. So please, Ram, introduce.
All right, folks. I'm here to talk about enterprise blockchain. Just a quick show of hands. How many of you are familiar with blockchain? Heard of it? Okay. So how many of you have owned Bitcoin or Ethereum or any cryptocurrency? Oh, okay. Quite a few. It's not a happy situation.
Anybody buy it at 19 cents?
So I'm not going to be taking any questions about cryptocurrencies. Focus is more on enterprise blockchain over here. So anybody played with any enterprise blockchain solution, stack, have a use case that they've explored? Okay. So quick overview of the agenda. I'm going to give a quick introduction to blockchain, overview of enterprise blockchain, and then we'll talk a little bit about what we've done at Cisco and some interesting use cases. If you played around with Bitcoin or any of the others, blockchain came around with Bitcoin being the first instance of blockchain with, the way I think about it, it's a cryptocurrency and a payment application on a blockchain infrastructure. And around 2016 is when there was a lot of interest around how to kind of use blockchain for enterprise applications. I've been looking at it for over 4 years now, and that's the time we found others in the industry who were interested in pursuing this, and we joined Hyperledger, which is an open source project hosted by the Linux Foundation, along with IBM, Intel, and other like-minded folks. And so that's when kind of the enterprise blockchain space kind of took off, if you will. And here we are in 2018. There's been a lot of hype around the technology and the space, but we are now realizing where the use cases make sense. We are seeing some early deployments. There have been lots of trials and POCs, and we'll talk about some of them. So what is blockchain? So it's the other term that you might have heard is a distributed ledger technology, or DLTs. So what blockchain is it's a shared digital ledger for recording transactions among a set of participants. And the set of transactions are stored in a manner that they cannot be altered. So-called an immutable log of all the transactions is available to all the participants in the network. In the case of Bitcoin, that is a ledger of all the transactions capturing who owns what, how many Bitcoins, and so forth. But in the case of an enterprise blockchain, it could be any set of transactions among a set of transacting enterprises. What is a distributed app? So in a regular world, you have clients and apps that could be, or services that are running on a cloud or in a data center. A distributed app is one in which the application, some of the business logic runs on the blockchain network itself, and you can think of the distributed ledger or blockchain as the decentralized database that stores the state for the app in a set of distributed nodes, and the app makes use of this decentralized state to kind of have business logic that manipulates and uses the distributed state stored in the ledger. And the smart contract is a piece of code that actually runs on each of these nodes that's used to validate the transaction requests that are sent. And this is used to automate the business process, the transaction logic that the distributed app uses. And that's used to validate the transactions. And once the transaction is validated, then that information is stored on the ledger, and it updates the current state, which is available on all these nodes. So genesis of blockchain, it started in 2008 by a paper was published, and the first source code came out. We don't know yet who this anonymous author is. And there was a lot of controversy on claims that they found who this was, and for all we know, it could be not just one person, but some agency as well. We have a Satoshi here. So the interesting thing is, a large amount of the original Bitcoin that was minted is still owned by the creator, and there's been no activity there. So there's a lot of money involved here as well that's unclaimed. So the Bitcoin blockchain network is an example of a public network which is permissionless, which means that any entity can join and participate in the network. They just run the open source software, Bitcoin software, and they can stand up nodes and participate in validating the network and so forth. And most of these nodes actually are maintained by quote-unquote miners that are in low power zones in countries like China and Russia and so forth. It is secure and immutable in the sense that strong cryptographic keys are used, as well as cryptographic algorithms are used to maintain the integrity of all these blocks. And it's a shared global ledger in the sense that every full node that's participating in the Bitcoin blockchain network has a full record of all the transactions that are there in the network from the Genesis block that was started in 2008. And the way we maintain consensus in the blockchain network is through a mechanism called proof of work, more commonly known as mining, which is a computationally very intensive process which actually consumes a lot of electricity. The whole blockchain network now consumes more electricity than the country of Denmark. So these are huge data centers filled with purpose-built ASIC-based hardware built just for this mining. And most of these data centers, like I said, are running in low-power locations, like China, which subsidizes electricity for industrial use, or places like Russia and other locations where people are able to access low power for purposes of mining. The other important aspect is that you can make the transaction programmable. Even in the Bitcoin network, you have the ability to quote-unquote create a smart contract which by putting in some simple business rules about what kind of transactions are valid. And not just have a simple transfer, but more complex business logic when you kind of execute a transaction. So we quickly realized when we started looking into this that the promise is not to use this just as a public cryptocurrency or a payment kind of capability, but for any type of business-to-business transactions, and that's what enterprise blockchain is all about. In this case, there's not one global public network like the public Bitcoin network or the public Ethereum network, but there could be purpose-built business networks which are permissioned peer-to-peer networks for an ecosystem, right? So one example where we've deployed this is in the Cisco supply chain itself, right? So Cisco is a example of a ecosystem supply chain network where we are a very horizontal organization and we outsource a lot of our manufacturing. Our boxes are completely built by our contract manufacturers. And so we have relationships not only with our contract manufacturers, but our tier 1 and tier 2 suppliers, our distributors, our logistics partners, and so forth. And when we receive an order that goes from us to our supply chain, it gets built to order, and gets delivered directly to our customers. And there's a whole network of entities that are participating in this ecosystem. So it's a permissioned peer-to-peer network in this case, built for the Cisco supply chain, which has as its members Cisco, our contract manufacturers like Flextronics or Foxconn, our tier 1, tier 2 suppliers, and so forth. And every one of the participants is a known entity, and all the nodes are associated with one of these enterprises. We use the same kind of secure cryptographic methods, so every transaction is still signed by the submitting entity, and every validating node uses its own credentials to kind of sign the transactions and the blocks that are added. So this is a shared ledger, but it's not a global ledger. Every node that is participating in this network has a copy of all the transaction data and the ledger. But it's restricted to just the members of this business transactional network. And in this kind of a partially trusted environment, instead of using the highly compute-intensive and power-hungry proof-of-work mechanism, we can use far more efficient protocols. You can think of them as similar to kind of the routing protocols in which the participating nodes are actually voting on what are valid transactions and what is the sequence and correctness of the transactions that are going to be included in every block as the blockchain progresses. And so that's the method that's used in enterprise blockchain. And in this kind of settings, we can make the smart contracts fully programmable. So you can use this to automate your shared business processes in a much more rich way compared to the very simple scripting capability that's there in Bitcoin as an example. So what's the value proposition in general? As we've had a number of hundreds of customer interviews, we captured and tried to generalize what are the problems that blockchain is good at addressing, right? So you can think of it the way, like let's take the example of the Cisco supply chain, right? Prior to using blockchain, the way it used to work is through a set of B2B EDI type interactions in which we've built a full mesh EDI capability between us and each of our ecosystem partners. And what happens is that each of these entities has their own version of the truth of their data in their own data centers, in their databases and ERP systems. And we use some kind of messaging protocol to kind of exchange information when we transact with our partners. Now, this kind of works fine as long as there's no discrepancy. As soon as there is a discrepancy, then there's no automated way of dealing with it. You're left with the operations teams on both sides sending emails, calling each other, trying to resolve the issues, right? And the whole promise of blockchain is to make that process much more frictionless, eliminate the reconciliation problem altogether, eliminate the effect of the data silos in the different organizations that are collaborating with each other by using the blockchain as a single source of truth among the participating entities. The next value prop associated with this is the tremendous increase in transparency and the correspondent lowering of risk associated with all these transactions, right? So you have the ability to share the same data among a set of participating entities in real time with strong cryptographic proof of who changed what, right? And so this gives you the ability to have auditability and compliance and in this kind of settings, and as opposed to the public Bitcoin kind of networks which try to say we are trustless and we trust the algorithms to maintain the validity of the network. In this kind of network, we are in a partially trusted environment. And it's a trust and high verify model, if you will. And this gives you the high verify because of the shared data with the strong cryptographic proofs associated with it. And last but not the least, we have the ability to automate the shared business processes, right? So using these smart contracts, we can actually encode the business rules when we are doing these transactions, that is changing the data that's on the blockchain. So this is a very promising, emerging technology. The way I think about it, it's at the intersection of distributed systems, security and cryptography, and databases, right? And it's still very early days, and there's a huge potential for this space. And the way I think about the value is that you can see layers of value depending on what is being shared. If you shared only the cryptographic hashes of the data on the blockchain, you have the ability, and you keep the data still off-chain, if you will. You have the ability to have data integrity by using the hashes to prove that you have correct data among each other. The next level of sharing is, besides the cryptographic hashes, if you also actually share the data, then you have the full transparency and the single source of truth and kind of the ability to have that replicated shared view of the actual data itself. And the next layer of value comes from the shared business logic with the smart contracts. You have the ability to kind of automate your shared business processes and get even more efficiencies with the assurance of the fact that you have this agreed upon pieces of code which is actually executed by all the nodes in a verifiable manner. So where we are today is that we have many small-scale deployments, lots of trials, and many small-scale deployments in different industries. And the Cisco supply chain example is a good one, where we have deployed this within our ecosystem. Right now, we have tens of nodes that are participating in the network. It keeps growing as we add more of our ecosystem partners and increase the number of applications and use cases that we target within the supply chain space. Similarly, there are financial use cases and financial blockchain networks. There are ones around IoT that we've recently done a POC on with a utility and so forth. But what we already see is that we can actually interwork these different networks. And our long-term vision is that we, just like the way the internet was built, not as one giant global flat network, but as many small networks that we then interwork with each other to allow end-to-end. Today in the internet, we have end-to-end communications. The end vision with enterprise blockchains is once we allow interoperability between these networks, we'll have the ability to do trusted transactions at the internet scale. Of course, that is still a long way off. We would have to work to create the open standards that allowed, just like we did in the internet space through IETF and so forth, where we created all the interoperability standards. We'd have to do the same to kind of get to this end vision. So, we are living in this world where digital transformation is happening, where enterprises are kind of dependent on this ecosystem. Our supply chain is a good example, but I'm sure all of you are living in a very digitized, interconnected set of networks. And new business models are evolving. And at the same time, there's increased risk of all the security problems that come up when you have all these different enterprises working together and so forth. And blockchain lets us solve many of these challenges through the transparency that it provides, reducing complexity and transaction cost, and really increasing security by having all these cryptographic techniques along with the cybersecurity capabilities that we bring from a regular security portfolio that we have at Cisco. So a little bit about Cisco blockchain. The three big themes that we have for the platform that we've developed is it's simple so that it's easy to deploy, manage, develop apps, and kind of operate. It is highly secure, built for enterprise with best-in-class security and the ability to manage privacy and confidentiality. We've developed some very unique capability. I'll talk a little bit more on how you can actually share data, but still have control about who gets to see what. And this is a problem we faced, and that's a hard problem to solve in the blockchain world, right? I mean, of course, when you put something in the public blockchain, it's available for everyone to see. Even in a private blockchain environment, in most solutions, if you have a blockchain network, when you share data, it's available for all the participants. And so but even in our supply chain deployment, they are willing to share information, but they want full control about who gets to see what information that's shared. And so that's a tough problem to solve in this space and a requirement that's come up over and over, and we've had some unique capability there. The last but not the least, it needs to be highly scalable, right? So that's the thing that we bring to the table as well. A quick overview of the stack. I won't go through the details. At the bottom is the infrastructure layer. For applications and use cases that needed, we also have the support for hardware security modules to keep your private keys completely safe. The next layer up is the scalable communications layer for client-to-peer and peer-to-peer communications. Remember, this is a peer-to-peer network of nodes that might be in different trust domains. The distributed ledger layer is the one that has the consensus protocol and takes care of validating all the transactions and maintaining blocks in the blockchain ledger itself. The layer above that is the smart contract layer. This is the layer that actually executes the code. We made that pluggable. We made the consensus framework pluggable as well. The first instance of our implementation supports the Raft protocol, which is fully distributed. And the first instance of smart contract is JavaScript. So we chose that because there's a wide, huge development community behind that. Identity and policy are managed right on using the ledger itself in a distributed manner. I wanted to emphasize that we've built this with end-to-end security. We've integrated this with our StealthWatch cloud security offering to have cybersecurity monitoring of each node. And we also kind of manage the performance of every node and the network as a whole through App Dynamics integration. And end-to-end analytics, both from a performance management as well as the ability to detect any potentially malicious or compromised behavior of any of the nodes is another capability that we are adding. So some of the unique capability compared to what else is out there, we are a fully decentralized network. For instance, the way we manage identity is through transactions. So anytime we enroll an entity into the network, that's done by transaction on the ledger itself. And we've actually built a decentralized certificate authority so that instead of having your credentials in a certificate that's managed by any one particular entity, we have the capability to kind of provide a decentralized certificate authority by a group signing mechanism such that the blockchain network as a whole is kind of vouching for the credentials and attributes that are there in the certificate. I talked about scalability. Fine-grained information confidentiality, as I mentioned earlier, is one of the unique capabilities that we have to kind of provide that fine-grained control about who gets to see what based on roles and groups and so forth. The other aspect I wanted to kind of also add is about that this is an object-oriented distributed ledger. So we have NoSQL objects as the way in which you kind of represent the objects with the schema attached for the fine-grained information confidentiality, so that the distributed application developers can use their typical NoSQL style of developing applications and representing objects on the ledger as JSON objects, as an example. Quickly touch upon use cases. There's a whole set of them that are out there. Supply chain, no surprise, is one of the leading ones. We ourselves have deployed our blockchain platform in our supply chain ecosystem that's deployed globally. So we have nodes running with some of our suppliers in Europe, in US, of course, with our Cisco centers, and as well as in Asia, where many of our suppliers are. Logistics, again, is a good example. There's a lot of activity in trade finance, which is, which has a lot of friction with things like bill of lading and supply chain finance, where blockchain has been used very successfully to eliminate friction, lower cost, enable new business models, and so forth. International payments comes up. You probably heard of Ripple. They have their own cryptocurrency as well, but they're actually going after the international payment space. Asset trading is a good example, which has a lot of friction. Again, the reconciliation costs when you have mismatched transactions is huge. So you have the banks are very interested in that. And decentralized identity comes up a lot, right? So when you have federated identity, still has a lot of issues. When you have silos of identity, you can use a blockchain to kind of provide a decentralized identity solution. Any of you have come across or have use cases which you think fall in any of these buckets?
I would think logistics for a company like Cisco as well. Like,
Yeah.
how are we using it internally?
We track the provenance of all some of the most counterfeited parts through our supply chain. And there are plans to use it as well for our RMAs and refurbished parts as well. So the other use case that we are thinking of is, and if you come to the world of solutions, you can see a demo of it, is for trusted compliance. So we are actually integrated with DNAC to capture and have an immutable log of all the configuration changes that are being made. And there are regulatory compliance requirements that come up, for instance, in the healthcare space or in finance, that you need to have the right segmentation and so forth. And what happens today is that an auditor comes in, a third-party auditor comes in, looks at your configurations and says, hey, you're compliant, or you're not compliant and you need to fix it. And they come in once a year and so forth. What this gives us is a real-time audit log, and say an auditor has their own node, they will have full visibility of these configuration changes as they are happening. And they can actually encode the compliance rules as smart contracts and automate the process of actually checking whether configuration changes, proposed configuration changes, are compliant or non-compliant, right? And so this could be in the real-time loop as opposed to a one-off audit process that's happening today. So that's something that we've implemented. The more forward-looking version of that is to add perhaps insurance providers, either cybersecurity or compliance checks, to kind of insurance, where they can have visibility and then based on that provide you insurance for cybersecurity or for compliance, because many of these banks end up paying fines if they are found to be non-compliant and so forth. IoT is another space where there are lots of interesting use cases. So this is showing a manufacturing plant where devices are being built. you can actually capture information about the condition of the manufacturing machines themselves as this is being built. And the next phase of that is then you have the provenance of the devices themselves. You can use the blockchain to capture both the provenance as well as the identity of the devices and manage the identity of the devices. And as well have it as a way of capturing the capabilities and typical behavior of those network devices, right? So that once it comes in and gets deployed in an enterprise, or in some cases it might be a consumer device as well, but we are primarily interested in the enterprise use cases, and you have the ability to kind of check whether it's a genuine device. You can have the metadata about the device to see what kind of behavior you can expect from it. And this can be all validated, assured information that has a strong cryptographic capability. So that's pretty much all I had. Open it up for questions.
I was curious if you've been able to measure any of the benefits by means of. Sorry, I'll repeat the question. So I was curious if you've been able to measure any of the benefits, like by means of cheaper, faster, better, or anything like that. As part of your use cases, I mean, have you been able to
Yeah, so I guess the most practical one is the first application that we've deployed in our supply chain network is anti-counterfeiting of our optical transceiver modules. Mm-hmm. So we capture the full genealogy of our parts when they're manufactured by our suppliers, and our brand protection team is now able to use an app. So what used to take them weeks to kind of verify the authenticity of the parts, now they can do in real time by using an app that scans the part, queries the blockchain, and can immediately tell you whether it has a full genealogy that matches the part or whether there's any discrepancy. So, so we have stats on what's the revenue lost because of piracy. That's one aspect of it. The other is just the improved efficiency, what used to take 2 to 3 weeks, because what happens is they might get a call, the brand protection team might get a call from customs to say, hey, we've intercepted something that looks suspicious, come out and check it. So someone from the brand protection team is going to go out to customs, and they have to look at it visually today. Before this was deployed, now they can actually use our app. Before this was deployed, they have to come and visually inspect it and decide whether they're going to intercept and stop that from being shipped to the customer, or to actually have that seized for further investigation. So that's a difficult choice, right? So what happens is if they seize it, then it takes typically 2-3 weeks for them to go back to the supposed source of that part, and for those guys to then dig through their systems and verify that this was either a genuine part or not. It takes them weeks before they can determine whether that's a genuine part or not. Right now, what happens in our blockchain system is that every event from when a brand protection label was manufactured to when the part was manufactured and the brand protection label was applied, and through when it gets sent to the contract manufacturer, when it was tracked through our logistics providers and distributors, all of those are recorded on the chain, so that when the brand protection team member goes in and scans the app, that information is presented, and they can see in real time. They can see whether that works or not, right? So that's real use case where you can either measure it as potential piracy spend, or in terms of the efficiency of the brand protection team in terms of how they can do that.
Okay, any other questions? I know we've run over a little bit, but we have an opportunity here, so otherwise we'll bring it to a close. Thank you very much, Ram. That's been great. Excellent.